what are the complex numbers in mathematics and how to deal with them? We have the simplest possible numbers in mathematics, which are real numbers. For example, 0, 1, 2. They can be either positive or negative, kind of -1, -2. So this is the real numbers, and I hope we already can deal with them quite freely. But what if I tell you that this is not the whole list, or not only possible direction of counting? So you can count not only the positive direction and the negative direction, but you can also go beyond this line, or in other words, up and down. This is so-called complex numbers. Actually, any number can be written as a complex number, but with a complex or imaginary part equal to 0. These real numbers actually lie on so-called real axis. If we draw the numbers axis, this is real axis, and it's usually marked as RE. But not all the numbers lie on this axis. Some of them may lie somewhere here, out of this plane, and these are complex numbers. If you actually have a look on numbers lying here, you always can write down, for example, not just 2, but 2 plus 0 g. This form of recording is typical for complex number. You have real part plus imaginary part. Usually, when you're dealing with real numbers, imaginary part equals to 0 and you don't use it at all. But in fact, any number can be represented in this form of record. There is a geometric meaning of complex numbers, which follows the simple x-y plane logic. So if we call the real axis as x-axis and imaginary axis as y-axis, things are going to be much more clear and simple. And any dot on this surface indeed can be represented with some two coordinates. For example, this something about 4 by x and by y-axis is going to be -2, this point. But if we're talking not about geometry, but about complex numbers, this number, which representing this dot, can be written as 4 minus 2g. This is basically the same meaning, but written in complex form. And it is important to understand. This is one number. There are not anymore two coordinates of the dot, but the whole structure is one number. You can do all the basic math operations with complex numbers in the same way as you do it with normal or real numbers. You can add them, subtract, multiply, divide, take the power of it, and do all the mathematical operations absolutely the same like with real numbers. Of course, it's not so simple to do it on the list of paper or in your head. There are some special rules how to work with these numbers. For example, when you want to add two complex numbers, you have to add separately real parts and separately imaginary parts. For example, if you take this number and you want to have a sum with another number, for example, like this, you have to summarize left part and then right part. -2 plus 3, this is +1. So this is the result. For basic operations, these rules are quite simple. For multiplication and division, a little bit complicated, but still doable. But when you use some advanced calculation tool, like MATLAB, MATLAB can do all these operations very fast and very easily, and actually MATLAB don't see a big difference between a real number or complex number. They are just numbers. What is actually G? Or sometimes it's used as I. This is actually some magic symbol which show you that this part is the imaginary part. In classical mathematics, we quite often use I, but in electrical engineering, I is usually current, so especially for electric people, we have G. This is only in electrics. But MATLAB understands both I and G, no big difference. And this I or G is actually, if we go in deeper to mathematics, is the square root of -1. What is this? Nobody knows actually. If I ask some of you, what is square root of negative number? Nobody can answer. It's not exist. And it was decided that if it's not exist, let this nonsense number to be marked as I. So this is just the square root of -1. And with this assumption, actually now you can take square root of any negative number. If you take square root of -4, what is this? This is the square root of -1 multiplied with square root of just 4, which is 2i or 2g. So with this assumption, you now actually can take the square root of any negative number. This is actually a big advantage of complex numbers. And now with this assumption, you can solve, for example, equations where with real numbers you would say there are no solution. But now there is solution. It's not real solution, but still at least some solution. Is it clear so far? What else I can tell you? There are also some special operations which can be done with complex numbers. There is operation of taking real part. The sign of this operation is this RE. There is operation imaginary part, which is usually written as IM. Also, you can take a module of complex number, which is just
The absolute value.
Yeah, absolute value or module. So you can take the absolute value of complex number, pretty much the same as it works with real numbers, but here it's a little bit more important. And you also can take angle of a complex number, and this operation is usually written as this, the sine of angle or towards n. So what does it mean? If you have some, for example, complex number like this, 2 plus 1g, what is real of this? It's equal to 2. What is the imaginary part of the same number?
1.
Yeah, yes, actually 1. What is the module? This is actually the length of the vector which is drawn from 0 point to the point with these coordinates. So it should be the square root of 2 squared plus 1 squared, something like that. And what is the angle? This is the angle between this vector and the real axis. So if we have this number like this, like this, so we can actually draw the line from 0 to the point with coordinates of real and imaginary part. And the length of this is actually module, and angle between this line and horizontal axis is angle of this number. That's all the characteristics which can be taken from the complex number. As you see from these characteristics, complex number can give you much more information than real number. So, and this is actually why we're using these complex numbers in electrical engineering, because we are very often interested in not only the absolute value of something, but also in angle, because we quite often dealing with vectors, also we dealing with sine waves or sinusoidal signals, which also has its amplitude and phase shift. Because of that, a lot of things in electrical engineering are written in complex numbers, but not real numbers. That's all.